Every year, more than 100 million tons of old asphalt are stripped from roads across the United States. But this is not an ending. It is the beginning of a new life cycle. As aging highways complete their service, they enter a process of renewal driven by technology, innovation, and sustainable thinking. Inside massive recycling plants under intense heat and extreme pressure, only to be reborn as pavement that is smoother, stronger, and cleaner. So how do humans transform millions of tons of worn-out asphalt into the foundation of new highways, expanding cities, and the next generation of infrastructure? Join Mandarin Tech as we step behind the scenes of this familiar yet remarkably powerful recycling process. The asphalt industry forms the foundation of modern infrastructure. In the United States alone, vehicles travel more than 3.2 trillion miles every year, a level of demand that depends on an enormous road network continuously built and maintained with asphalt. This sector supports millions of jobs and contributes over $300 billion to the global economy. Through it, goods, people, and energy move efficiently, keeping the modern world in constant motion. But behind this critical role lies a heavy environmental cost: intensive petroleum use, significant CO2 emissions, and a rising volume of construction waste. Caught between economic pressure and sustainability goals, asphalt recycling has become a crucial answer. Thanks to its near-limitless recyclability, worn road surfaces can be milled, reheated, and blended into new pavement that rivals virgin material in performance. This ability is reshaping the infrastructure industry, turning yesterday's highways into tomorrow's resources and pointing the way toward a more sustainable future for the planet. Have you ever wondered how long an asphalt road can serve before it needs replacement? On average, the pavement begins to deteriorate after 10 to 15 years, as the continuous stress from vehicles, weather, and oxidation gradually strips the bitumen of its flexibility. Cracks, potholes, and rutting start to appear, clear signs that the surface has reached the end of its life. When patching or thin overlays are no longer effective, the first stage of infrastructure renewal begins, breaking up the old asphalt layer to recover recyclable material. In this phase, the construction crew performs preliminary surface demolition to isolate heavily damaged areas before large-scale milling. Workers use road saws equipped with diamond or carbide blades to cut boundary grooves 2-4 inches deep, defining the work zone and preventing cracks from spreading to the usable pavement. Next, pneumatic jackhammers are used to fracture and separate thick asphalt sections, especially around manholes, drains, and edges where larger machines cannot operate. These tools run at 80 or 100 psi, delivering thousands of blows per minute, powerful enough to break the asphalt apart while leaving the foundation layer intact. Once the asphalt slabs have been separated, wheel loaders or mini excavators move in to begin the removal and collection phase. Operators carefully lower the bucket to the edge of each cracked slab, then lift gently to pry the entire section up without damaging the base layer underneath. Smaller pieces are gathered into clusters before being loaded onto trucks, while larger slabs are broken apart using the bucket or steel bars for easier handling. When the asphalt remains tightly bonded, workers assist with shovels and pry bars to loosen the edges, allowing the machinery to work faster and more efficiently. Each bucket can hold between 200 and 400 pounds of asphalt, and within just a few hours, dozens of tons of material are cleared from the road surface. Trucks are weighed, assigned batch numbers, and logged with their excavation zone before leaving the site, ensuring full traceability of the RAP, reclaimed asphalt pavement, for future quality control. Once the surface has been completely stripped, the crew performs mechanical sweeping and base leveling to prepare for fine milling in the next stages of recycling. Though it may seem like a straightforward task, this phase determines the precision and efficiency of the entire recycling process, where every slab of asphalt is separated, collected, and made ready for its journey of rebirth. After the old pavement is removed and transported from the site, all the material, known as RAP, reclaimed asphalt pavement, is sent to a recycling plant. Here, every ton of used asphalt begins a process of separation, cleaning, and size standardization, preparing it for the next stage of mixing. The first step is impurity removal. Trucks unload the wrap into a feed hopper, where the material moves along a vibrating feeder that separates debris, soil, scrap metal, and concrete fragments collected during milling. Large metal pieces are extracted by an electromagnet, while the remaining material enters the impact crusher, the core of the entire processing line. Inside the crushing chamber, high-speed hammers, rotating at 1,800 RPM, continuously strike the asphalt against fixed impact bars, breaking the chunks apart and separating the aged bitumen from the stone aggregates. Adjustable impact wings allow operators to fine-tune the gap between the rotor and the bars, controlling the output size, typically ranging from 0.5 to 2 inches, depending on regional or manufacturer mix specifications. After crushing, the material passes through a multi-deck vibrating screen for classification. Oversized particles are recirculated back to the crusher, while properly sized aggregates are divided into groups: coarse wrap, fine wrap, and mineral dust fines. Some plants also include an air separator to remove light dust, ensuring cleaner aggregates and improving binder adhesion during remixing. In modern facilities, the entire process is automated and monitored through sensors that track vibration, temperature, and material flow, ensuring consistent quality of the processed wrap. On average, a single plant can handle between 100 and 300 tons of wrap per hour, recovering up to 30–40% of material ready for direct reuse in new asphalt mixes. This is one of the most critical stages in asphalt recycling, where old pavement is reborn into a clean, uniform, and valuable resource, ready to enter the drying and heating phase of a fully closed-loop process. After being crushed and screened, recycled asphalt material still contains significant moisture and impurities, which prevent the aged bitumen from bonding effectively with new aggregates. Therefore, before blending, the RAP must undergo a drying and heating stage to restore it to an optimal state for reuse. At the plant, the RAP is fed into a rotary drum dryer, a massive steel cylinder slightly inclined and rotating continuously along its axis. Inside, natural gas or fuel oil burners generate a stream of hot air reaching 250 to 300 degrees Fahrenheit, which flows counter to the material's movement. As the wrap tumbles along the inner walls of the drum, moisture gradually evaporates, and the bitumen softens once again, allowing the mineral aggregates inside to separate evenly. In modern production lines, temperature and airflow sensors constantly monitor the process to prevent overheating or oxidation of the aged binder. Many facilities use a double-barrel drum mixer system, which heats the wrap indirectly through hot air rather than direct flame contact, preserving the chemical integrity and performance of the rejuvenated asphalt. After being crushed and dried, the RAP, reclaimed asphalt pavement, moves into the mixing phase, where old material is combined with fresh aggregates, bitumen, and additives to form the final asphalt mix. In modern asphalt plants, every material is automatically weighed and precisely proportioned. New aggregates are heated in the drying drum at 300 to 350 degrees Fahrenheit, while the RAP is only heated indirectly, just enough to soften the aged bitumen without evaporating its essential oils. The two material streams meet in the mixing drum, where continuously rotating paddles blend the old and new binders together into a uniform mixture. The RAP ratio typically ranges from 20 to 50% in standard plants and can reach up to 70% in facilities that use rejuvenators, compounds that restore the elasticity of aged bitumen. The entire process is monitored through temperature and bitumen flow sensors to ensure every aggregate particle is evenly coated. Once the desired consistency is reached, the finished mix is discharged into a hot silo and maintained at 275 degrees Fahrenheit before being transported to paving sites. This marks the true rebirth of asphalt, when material once discarded is recombined to become the foundation of new roads once again. Immediately after the recycled asphalt mix is blended, it is discharged into specialized dump trucks whose beds are preheated to prevent the asphalt from sticking or cooling too quickly. The temperature at the time of loading typically remains around 270 to 300 degrees Fahrenheit, allowing the mix to retain its plasticity and self-leveling ability during paving. Each truck leaves the plant on a scheduled route, heading to the construction site where the paving crew has already prepared the base surface. Upon arrival, the driver raises the truck bed and unloads the hot mix into the hopper of the asphalt paver. This machine uses a screw conveyor, auger, to spread the material evenly across the full width of the lane, while the screed plate at the rear lays the asphalt at a precise thickness, usually between 1.5 and 3 inches, depending on the pavement type. Right after paving, steel wheel and pneumatic rollers begin compacting the still hot layer. The rolling sequence is carefully planned. The steel roller provides initial compaction and smoothness, while the pneumatic roller seals air voids and enhances cohesion. The entire process must be completed before the temperature of the mix drops below 180 degrees Fahrenheit, as the bitumen would otherwise lose its optimal bonding ability. Within just a few hours, the recycled asphalt layer hardens and is ready to reopen for traffic. Roads once thought to have reached the end of their life are reborn, saving thousands of tons of material and significantly reducing carbon emissions, a clear testament to the power of recycling in modern infrastructure. After millions of tons of old asphalt have been milled, crushed, and reborn into new pavement, the recycling process still isn't over. To make roads stronger, quieter, and more resistant to cracking, engineers turned to another unlikely source: used tires. Once considered one of the most problematic waste materials in transportation, discarded tires have now become a valuable additive in advanced asphalt mixtures. Millions of discarded tires are now being collected, processed, and transformed into renewable materials, opening a new journey where old wheels no longer end up in landfills, but instead become part of the very roads they once rolled upon. This journey begins with the collection and stockpiling of old tires. At service garages, repair shops, and tire replacement centers, millions of worn, cracked, or damaged tires are gathered every year. Those still in usable condition are retreaded, while the rest are transported by specialized trucks to collection facilities for recycling. At these facilities, workers sort, clean, and remove metal components, such as steel belts and embedded nails. The yards can store tens of thousands of tires at once, stacked neatly in enclosed areas to prevent fires and contamination. Once prepared, each batch is sent to a rubber recycling plant, where the tires undergo mechanical or cryogenic grinding to produce crumb rubber, a key ingredient that takes recycled asphalt to a whole new level of durability and sustainability. After being collected and cleaned, used tires are sent directly into a continuous industrial grinding line, where they are transformed from tough, durable material into reusable rubber powder. Each tire, originally designed to withstand tons of load and constant wear, must undergo a rigorous processing sequence to separate its components: rubber, steel, and synthetic fibers. Conveyor belts automatically feed each tire into industrial shredders. These systems use wear-resistant alloy shafts rotating at hundreds of revolutions per minute to cut, tear, and grind the tires into small fragments. Modern equipment can process whole tires directly, without pre-cutting, producing shredded pieces just a few millimeters in size in a single pass. During grinding, a low-pressure water spray system cools the blades, reduces friction, and prevents the rubber from overheating or catching fire. In advanced plants, this process can be further enhanced with cryogenic grinding. By cooling the rubber with liquid nitrogen to around 300 degrees, the material becomes brittle and easier to fracture, allowing the mill to produce crumb rubber with uniform particle size, sharp edges, and minimal impurities compared to conventional methods. The resulting powder typically ranges from 0.5 to 2 milliliters and is tested for moisture content, remaining metal fragments, and elasticity to meet asphalt-grade specifications. Once the desired fineness is achieved, the crumb rubber is dried in a hot air chamber, then cooled and bagged in a dry, sealed environment to preserve its natural elasticity. Each ton of tires can yield approximately 700–800 kilonewtons of standardized crumb rubber, which is then transported by tanker trucks or large bags to asphalt plants. There it is blended with bitumen and mineral aggregates to produce rubberized asphalt, a next-generation material combining mechanical strength, elasticity, and environmental efficiency, completing the full recycling journey of the used tire. From reclaimed asphalt panels to tires that seem to have reached the end of their life, every piece of material is fully reborn, becoming a valuable resource for new roads. This closed-loop process, removal, shredding, drying, mixing, and paving into rubberized asphalt, not only extends pavement life, reduces noise, and increases durability, but also significantly cuts industrial waste, contributing to environmental protection. It stands as a clear example of how humans can maximize resources by combining technology and ingenuity to turn waste into tangible value, while paving the way for a more sustainable transportation future. If you find the journey of recycling asphalt and used tires fascinating, hit like, share your thoughts in the comments on the step that impressed you most, and subscribe to the channel so you don't miss other inspiring industrial journeys.